let's go over some examples of finding the reference angle. So when you're finding the reference angle, first thing that you want to do is go ahead and draw the original angle. Determine what quadrant it is in. Our first angle is 52 degrees, so it's in quadrant 1. Remember, my drawings aren't to scale, but we have 52 degrees. Your reference angle comes in from drawing your triangle that you would use to solve our trig identities. In this case, since we're in the first quadrant, our reference angle is the same as our original angle, 52 degrees, because to get from our ray down to the x-axis, we would need the original 52-degree angle. For our next example, we have theta is equal to 205. So let's go ahead, draw in our axes. Remember, it's 0 degrees, 90 degrees, 180, 270, and then we're back to 360. So 205 degrees is more than 180, so we're going to wind up in quadrant 3. Again, not to scale, but we know that my original angle is 205, and 205 degrees is in quadrant 3. To find our reference angle, remember, this is the guy that will get us to the x-axis. So we want to know the angle within this little triangle here. That means to find our reference angle, we need to take our 205 and figure out how much we went over the x-axis by. What angle would this be if I was drawing my triangle? We find out that our reference angle is 25 degrees. So if we were working to find the trig functions of this triangle, I would start out by saying that my reference angle, bar theta, is equal to 25 degrees. All right. I know that most of you hate radians, but that's okay because it says our reference angle needs to be in degrees. So let's first convert our original angle from 65 pi over 36 to degrees by taking 180 over pi, multiplying that by our original angle. Remember that the pi's cancel out. If we take 65 times 180 and then divide by 36, we have 325 degrees. That is our original angle. We have not found our reference angle yet, just the original. So let's go ahead and graph it. Go ahead and give yourself your x and y coordinates. Remember 0 degrees, 90, 180, 270, and then back to 360. 325 is more than 270, but not quite to 360. So we're going to be in quadrant 4, which means that our original angle is all this outside piece. And we want to know the inside angle, our reference angle. So again, if I was drawing one of my triangles along this ray that 325 produced, I want to know what's going on inside here. What would create my triangle inside? To do that, to find our reference angle, we would be coming up to 360. So we're going to take 360 minus 325. And our reference angle is 35 degrees. It's how far do we need to move to get to the x-axis, either 180 or 360. Notice I am not using 90 or 270 when doing these calculations. This time we have theta equal to negative 250. So when we draw our graph this time, negative 250 means we are going clockwise. We normally go counterclockwise, which means that we would have negative 180. Down below, instead of 270, it's negative 90. Negative 270, because remember, we're traveling clockwise. Negative 250 is in between negative 180 and negative 270. So starting at our x-axis, because we had our standard normal form, it's going to come around, and now we are in quadrant 2. Negative 250 degrees. Okay, negative 250 is in quadrant 2. I forgot to mention the last one was in quadrant 4. Okay, but we're in quadrant 2. And our reference angle, what would we need to have to create our triangle to do our trig functions? So this little angle in between our ray from theta and our negative 180 is going to be right here. Okay, remember that 180 on our x-axis is the same thing as negative 180. So here, trying to find what this is, we have 250 and it goes over the 180. It's more than 180. So our reference angle, we're going to take 250 minus the 180 and find out that our reference angle, what would be in the angle of our little triangle here, would be 70 degrees. So if we were trying to work with this reference angle to do our trig functions, the inside here, that angle would be 70 degrees.